Hello. I hope your day's been swell. This is the 6th episode, I think, of Let's Worldbuild. This episode, I want to go over just like the general planet making process. You can see I got a planetoid building tab up right there. So I got my references. Only one of the planets, I want to go through the innermost planet, the innermost rocky planet. And I've decided that I will not be going through every single planet on film, at least one by one. And that's because it would just take too much time, and it would probably be kind of boring. TBH. This is a rocky planet that I'm about to do. And then I also want to go through, obviously, the main planet, at least one gas giant. I'll only go through the main planet after going through everything else that I need to in the solar system. So some dwarf planets as well, maybe a couple comets, the 3 asteroid belts that I got going here as well. So it's going to be fun. We're going to have a good time. Oh, and there was a little bit of a break between this episode and the last one, you probably noticed. And that's because I was at the beach for a week and it disrupted my workflow. And so now I'm trying to get back into things. So I have some notes here to start. And immediately I realized this in the editing of last video is that I somehow forgot to address this note. So this is from 2 episodes ago. And this is referring to the Decastar volume calculation. I don't think I didn't actually go over the specific steps that I used in calculating this, but I realized that it is really wonky. And I honestly don't actually remember what I did wrong, because at this point, me realizing what I did wrong was like 3 weeks ago, a month ago, something like that. So I'm just going to redo this real quick. The actual process here is that got to do solar masses divided by solar densities. Solar density can be found in this page, which, I mean, it's right here. Solar density, sol. And I have it on my phone's calculator right now. It is 1.484 solar volumes. So that's pretty cool. Rename the system type. This is because it's a little bit silly to name this a stellar system, because it evokes images of just like a bunch of stars. I think naming it a solar system just makes more sense because, it evokes an image of our solar system. This last one is another thing that I realized in post, which is that if I go to the system tab, I'm pretty sure like Neptune, which is the farthest out main planet, is only like 35 AU about. And so having a planet that's like 39,000 AU. So I'm actually going to fiddle around with these a bit more. I still want some gaps. I want some interesting gaps, and I still want the last one to be a lot farther out than any planet that we have in our silly little solar system. So I'm thinking like putting the last planet right here at 600 AU, which is still really far out, but it's not nearly at these sorts of distances. That's kind of crazy. Oh, and I have to change this value. It is now 614. But now this brings to mind, is this enough room for a asteroid belt? And I'm not sure. I'll keep a 3rd asteroid belt, and if this proves, like if I do some future research when I'm doing the asteroid belt episode, and it turns out that this isn't really possible, then I'll change it then. But for now, I'll keep it at the classical 3 asteroid belts. So now, to get into our first little planet here. Well, first of all, I gotta name it, and that's always the slightly tricky first step that we have to go through, but that's fine. I'm going to be kind of silly with this. I'm going to be kind of stupid since, all of these planets will be renamed anyways. I'm going to name this one the Very Hot Planet because it's very hot, very close into its star. It's going to be kind of like a Mercury clone, though I want it to be a little bit different, as you'll see. And I say that without even knowing exactly what I'm going to do with it. But that's the wonder of creation now, isn't it? So let's get planetoid template going. Copy all of that, create this, paste, tags. Now for the general description. This planet is the closest in to its parent star and is thus extremely hot. And this is not to say that there can't be a planet that's even hotter than this one that's a bit farther out, sort of like the Mercury-Venus sort of thing. And I probably will have some form of that, since greenhouse planets are pretty interesting to me. And I think it would be kind of boring for every planet to just be a Mercury clone, just a rocky wasteland sort of thing, except for the main planet, so I want to keep things a bit interesting. So this section is going to be very similar to the star section, but with a few, star-specific omissions and some planet-specific additions, like, I'll get into it. So the location is very easy. It's just the Deca system. Appearance. What should this thing look like? A bright orange planet with red streaks running through the surface. So I want this planet to be very bright, very in-your-face sort of thing. Mercury to me is just like this gray little void of a planet, and so even if there's no life on this one, I want it to be kind of interesting. I don't know, I like color. It's pretty cool. I guess as you can kind of tell. So now to get into some stats, the age is going to be the same as the star and, as the solar system itself. I'm just going to copy this. The type of planetoid is planet. Shape, the classic oblate spheroid that the Earth is, and what all the other planets are, I assume. Though correct me if I'm wrong on that. So dimensions, only radius is relevant. Well, for all of these sorts of details, I'm going to open up the Worldsmith and go to the Planet tab. So we already have the stellar mass here, and now we get into some of these things. So you can see the editable values here. So you've got your mass, you've got the core mass function, or fraction, which is the percentage of the planet's mass that is in its iron core, or, in its core. And this isn't a habitable planet, so you don't need to follow this advice right here. The tilt, the rotation, albedo, which is basically just how much of the starlight is being reflected off of the surface. For our purposes here, it's really just going to be how bright it is in the sky, that sort of thing. Greenhouse effect. I'm just already going to put this at 0, since this planet is close enough to its star that all of its atmosphere is probably going to be blasted off by, solar winds, solar flares, stuff like that. So I think it's pretty safe to assume that there's going to be no atmosphere here. This is a pretty neat tool right here, but we don't need it. And I'm going to go back up and edit those other values in a moment. We have some useful orbital characteristics that we can use. Atmospheric stuff is easy. There's no atmosphere. And that is basically that. So, how big do I want this to be? Well, I'm going to get a reference. So I want to see what its mass is relative to Earth. Okay, so that's actually a good bit smaller than I was expecting. I won't make it that small. I'll make it about double what Mercury is itself, so like 0.101. This puts the radius at around half of the radius of Earth, which I think is actually bigger than Mars. Come on, radius. Oh no, that's actually a bit smaller than Mars. And I'm not going to make the CMF especially important here, and in fact I'll just put it at a random value like 23% or something like that, which it actually looks like that made the radius a bit bigger. How much do I want this to be tilted? I kind of like the idea of this being more tilted than Earth, so maybe something like 34.5 degrees. So it has prograde rotation, which is that it spins in the same direction as its host star, which is every planet except Venus. So rotation period. As far as I'm concerned, this isn't really correlated with distance from the star. So I'm just going to put in a semi-random value here. I'll make it shorter. I'll make it like half of Earth about. So like 13.4 Earth hours. Get a little kick into its spin, into its days. Venus has a really high albedo. Oh my goodness. And I'm going to make this a bit larger than Venus. Make it really reflective. So something like 0.71, I think that's kind of cool. Which, what did that do? That actually, yeah, that put the surface temperature down a good bit since, some of the light is being reflected. This is still, wait a second. Okay, I got a bit spooked there for a moment because I haven't put in any of the orbital characteristics yet. And I saw this and I was like, wait a second, that's actually kind of cold. I can actually just input the orbital value from the planetary system since we have the orbit here. 0.45 AU, which now that is quite warm. Eccentricity, so how stretched of an ellipse will this orbit be? I'm thinking a bit more than Earth, something along the lines of like 0.02. Not especially bigger, but these values aren't going to be especially big unless you're like a comet or something. For a very stable planet, if it has a very high eccentricity, then it's going to interfere a lot with the other orbits and vice versa. So the other planets will interrupt its orbit and then, equilibrium will be found eventually. And then the eccentricity will get a lot less. Okay, so inclination, this is in respect to the habitable world's orbital plane. And so how inclined? I don't want it to be that inclined. None of the planets are especially inclined with each other. I think the greatest degree is like 5 degrees, maybe. Though I could be very wrong on this. I'll put it at like 0.98 degrees, so almost a whole degree. I might have just accidentally copied that number, but I don't really care. My brain is weird. That is all the values that I need to make for this document. And now I'm just going to copy all these over. Centimeter to the centimeter. Yes, that's a value. Interesting to note is that the year on this planet is only 100 Earth days, or about 200 of its days. It would be a little bit less than 200 since this is a bit over half of an Earth day. Doesn't have a climate, Lamau. No rings. I think I said at one point that I wanted this to be tidally locked, but looking at the data, I've realized that this planet, it's only a little bit farther in than Mercury is for the sun, and the star is only a little bit bigger than our sun. This is a difficult decision. I'm not sure if this planet would be tidally locked or not, because Mercury isn't. Yeah, Mercury's rotation is pretty dang large. Or I guess slow, Lamau. Okay, yeah. I'm actually going to change its rotation period to be a lot slower, just because it makes sense for this planet to be like almost tidally locked. I believe Mercury's rotation is like 2/3 of its orbital period, since it's quite close into the, to the sun. So I'm going to go for the same sort of thing here. Not quite equal though, not quite tidally locked, but if it was like a bit closer in, then it would be there. So I'm going to do a quick little calculation here, since gotta convert from 98. So 2/3, around 65. So 65 times 24, about that many hours. So 1560, which is a very long day. So albedo is 0.71. So tidal locking is an official nah. Tides. So an interesting phenomenon that you'll see with planets that are really close into their stars is that, as you can see here, tides from the planet star they're larger when compared with the Earth, but not noticeable. But when a planet is pretty close into its star, you see this with moons. Some volcanic activity can arise due to the tides of the parent body. The moons of Jupiter, some of them are really close in relative to their sizes, and so they are very much tidally affected by Jupiter. In this case, it wouldn't be to that extreme of a degree, but so it would only really be minor volcanic activity, I believe, but still present, which would also cause some seismic activity as well. No oceans, and so no continents. That was a bit scatterbrained, but I'm just going to go back to the top and then go through everything that is relevant from here. Volume is very easy. 0.123 Earth volumes. An interesting number to arise, but that's what I've calculated here. Layers, it's not especially relevant. I'm unsure about these two, so I'm only going to fill in this value. So the core is going to be smaller compared to the Earth's core, proportion-wise, and I don't have numbers on the exact values here, so I'm just going to skip that. Overall motion is pretty simple. So orbits around the Decastar in a nearly circular orbit, since even though it is an ellipse, but the eccentricity is quite small enough that it's basically a circular orbit. Actually, what's the eccentricity of Mercury? So the eccentricity of Mercury is 0.2, which reminds me that I'm pretty sure the closer in an object is, the more eccentric its orbit will be. I don't know, it's some weird orbital stuff. I'm not sure if that's correct, but just in case it is, and it doesn't really hurt that much to assume that it is in this case, and it would hurt if it was true. Hopefully that makes sense. But I'll keep the number that I had, but I'll just multiply it by 10. I think that's pretty easy. Satellites. This planet is close enough into its star that it's not going to have any natural moons. Get rid of that. Mercury and Venus both have no moons. Surface gravity is a little bit less than half of Earth's. Things are going to be very light on this planet. I'm going to leave composition blank for time purposes, but if it becomes relevant in the future, then I'll come back to it. In general, there's going to be a lot of iron, silicon, carbon, those sorts of elements, and a whole bunch more sprinkled in there, and I'm probably forgetting some major ones as well. It's not especially relevant right now, so I'm going to assume that the core is dead, since it's a relatively small core, and so, given the timescales that we're working with, it would have solidified. There is a fair argument to be made that it might be kept a bit liquid due to the tidal forces, though. So I'm actually going to say that it has a minor magnetic field. So the core being kept a little active due to tidal forces, there is a minor magnetic field. And I'm actually just going to copy that over to these two as well, except edit these specific values, since, it's the same explanation. So the landscape, this is actually the funnest part of this whole page, IMO. There's some good creativity that can come from this. And so what am I thinking? The landscape is varied, with scattered mountain ranges formed due to early volcanic activity. The planet is pocked with craters, though not as many as expected, since the planets outside it shielded it some from heavy bombardment periods. There are 4 planets outside of this one, so, I'm assuming that it's going to have at least a little bit less craters than some of the ones outside of it. I think that makes sense. Even if this isn't necessarily the case, the volcanic activity over time will also erase a lot of craters. That's another big reason why there's going to be less craters than some of the other planets. And on that note, there are also wide volcanic floodplains. This is a pretty wacky looking planet. It's got some Earth-like features with mountain ranges and wide plains, but there's also a bunch of craters. It's got some variation there. Magic, not relevant to the planet as a whole. There's no native life on this planet, so that is that. I'm going to leave it there for this episode. It was hopefully not especially long. Next episode we'll be going through, I'll say the first asteroid belt. I'll go through an asteroid belt in the next episode, since that's the next on the rung going outwards, other than the habitable planet, but that'll be last for the solar system. Though the next video on this channel that I want to upload is the second world building showcase episode, since it's been a while since I posted the first one, and then I posted a little sneak peek. I want to get that out. It's been a while. In other news, I have started a third channel, which is a lot different than the other 2 channels. It is very highly edited. I want to stretch some of my editing muscles, and I'm very excited about it. Getting into some other YouTube spaces. So if you're interested in some like history, science, gaming videos, then, basically anything goes on that channel. Yeah, feel free to check that out. It's called Jortney. It'll be linked in places. Alrighty, dighty. Well, I will see you next time. Farewell.